We end tonight with the clearest pictures yet of Neptune, the most distant planet in our solar system. What we have discovered from Neptune's first real images is nothing short of extraordinary, and for some, absolutely terrifying. For centuries, Neptune has been shrouded in mystery, sitting at the outer reaches of our solar system, distant and enigmatic. Named after the Roman god of the sea, this ice giant remained a theoretical concept until its discovery in 1846, based solely on mathematical predictions. But even after its discovery, its true nature was locked behind a veil of immense distance and technological limitations. Until now, the new images of Neptune, captured by the most advanced space telescopes and probes humanity has ever developed, have revealed stunning and unsettling insights into this icy world. These revelations challenge our understanding of the solar system, the potential for alien life, and even the stability of our own planet. What lies beneath Neptune's swirling blue atmosphere? What forces are at work in this distant region of space? And what does it all mean for the future of humanity? To fully grasp the implications of these discoveries, we must start at the very beginning, where Neptune fits into the story of our solar system. Unlike Earth, Neptune is classified as an ice giant. This means its composition is dominated not by rock or gas, but by volatile elements such as water, ammonia, and methane frozen into exotic forms. Due to its incredible distance from the sun, temperatures on Neptune can plummet to an unimaginable minus 373 degrees Fahrenheit, making it one of the coldest places in the solar system. But recent observations have shown that this frozen world is far from lifeless. The first real images of Neptune, captured by NASA's James Webb Space Telescope, have unveiled activity on this planet that defies our expectations. One of the most jaw-dropping discoveries has been the presence of massive storms, many larger than Earth itself, churning across Neptune's atmosphere with violent energy. These storms are fueled by winds that are the fastest in the solar system, reaching speeds of up to 1,200 miles per hour. Even more intriguing is the mystery of Neptune's dark spots, colossal, Earth-sized storm systems that appear as dark patches on the planet's surface. Until now, their origin and behavior have baffled scientists, but with the new data, researchers have begun piecing together the puzzle, and the answers they are uncovering are chilling. These dark spots seem to form in Neptune's deep atmosphere, where temperatures and pressures are extreme enough to potentially create diamonds. Yes, diamonds raining down to the planet's atmosphere in what can only be described as one of the most alien phenomena we have ever encountered. But the diamond rain, while fascinating, is only the beginning. The real terror lies in the unexplained energy source that appears to be emanating from Neptune's core. Observations show that Neptune is radiating more heat than it receives from the sun, a phenomenon scientists have struggled to explain. This has led to theories of internal processes, possibly involving radioactive decay or other unknown mechanisms, that are heating the planet from within. The implications of this discovery are profound. If Neptune has an internal heat source powerful enough to defy its frigid environment, it raises questions about the potential for subsurface oceans. And where there are oceans, there is the possibility of life. Could Neptune or its moons harbor alien organisms in hidden aquatic realms? Some scientists believe it is not only possible but likely. Among Neptune's moons, Triton stands out as a prime candidate for extraterrestrial life. Triton is unique in that it orbits Neptune in the opposite direction of the planet's rotation, suggesting that it was once a rogue object captured by Neptune's gravity. This moon is covered in a layer of nitrogen ice, and evidence suggests that beneath its frozen surface lies a subsurface ocean. Recent images have even shown plumes of water vapor erupting from Triton's surface, hinting at hydrothermal activity, an essential ingredient for life as we know it. But if these discoveries inspire awe, they also provoke unease. For one thing, the plumes on Triton could be releasing materials into space that might one day reach Earth. While this might sound like the plot of a science fiction movie, it is a scenario scientists must consider seriously. Could alien microbes hitch a ride on interplanetary debris and contaminate our planet? The answer remains uncertain, but the possibility is enough to give pause. Another chilling discovery from Neptune's new images comes in the form of its magnetic field. Unlike Earth's relatively stable magnetic field, Neptune's is chaotic and tilted at a bizarre angle relative to its rotational axis. This misalignment causes the magnetic field to wobble wildly, creating regions of intense radiation. For any spacecraft or future human explorers, this radiation would pose a significant hazard. But perhaps the most unsettling aspect of Neptune's magnetic field is what it suggests about the planet's core. Some scientists believe that the chaotic magnetic field could be evidence of an unstable interior, possibly a core that is in the process of breaking apart. If true, this raises a question. Could Neptune one day experience a catastrophic event that would send shock waves through the solar system? The thought of an ice giant destabilizing is almost too terrifying to contemplate, but it is a scenario that cannot be ruled out. As we dive deeper into the revelations from Neptune's first real images, it becomes clear that this distant world is far more dynamic and far more dangerous than we ever imagined. The discoveries challenge our understanding of planetary science and force us to confront the fragility of our own existence in the cosmos. One of the most profound lessons from Neptune's new images is the sheer unpredictability of the universe. For centuries, we have looked to the heavens with a sense of wonder and curiosity. But as our technological capabilities advance, we are beginning to see the cosmos for what it truly is: a vast, chaotic, and often hostile environment. Neptune, with its violent storms, chaotic magnetic field, and potential for alien life, serves as a stark reminder that the universe is not a safe place. Yet, there is also hope to be found in these discoveries. By studying Neptune and its moons, we are expanding the boundaries of human knowledge and pushing the limits of what is possible. Each new revelation brings us one step closer to answering some of the most profound questions about our place in the cosmos. Are we alone in the universe? What forces shape the planets and stars? And how can we ensure the survival of our species in an ever-changing universe? In the end, the first real images of Neptune are more than just scientific data. They are a testament to humanity's unyielding quest for knowledge and understanding. Curiosity and determination to explore the unknown remind us that even in the face of terrifying discoveries, we must continue to seek out the truth. It is only by understanding the universe that we can hope to find our place within it. Would you like me to expand on specific elements, such as Triton, Neptune's storms, or the implications for humanity? Let me know as we delve further into Neptune's mysteries. The planet's storms deserve closer scrutiny. These aren't ordinary weather patterns like those seen on Earth. Neptune's storms represent a level of meteorological chaos we've never observed anywhere else in the solar system. The recently captured images reveal vortexes that are massive enough to swallow the entire Earth whole. These storms aren't fleeting phenomena either. Unlike hurricanes or typhoons on our planet, which dissipate over time, Neptune's storms seem to have a strange persistence. Take, for example, the Great Dark Spot, first observed by Voyager 2 during its historic flyby in 1989. At the time, scientists estimated that the storm measured about 13,000 kilometers in diameter, nearly the size of Earth. What's especially fascinating is that new observations from the James Webb Space Telescope suggest that Neptune's storms might operate on cycles we don't fully understand. Some disappear, only to reappear in slightly altered forms, as if the planet itself is replaying patterns of violent turbulence. What powers these massive storms? One might assume that Neptune's distance from the Sun, nearly 4.5 billion kilometers away, would result in minimal atmospheric activity. After all, it receives only a tiny fraction of the solar energy that reaches Earth. But paradoxically, Neptune has the fastest winds in the solar system, reaching speeds of up to 2,000 kilometers per hour. These winds are strong enough to strip the surface of any solid object caught in their path. Recent studies suggest that these winds are powered by heat escaping from Neptune's interior. It's an internal energy source, not sunlight, that drives the planet's ferocious weather. But this theory raises further questions. If Neptune is generating so much heat internally, why isn't it visible in infrared imaging the way Jupiter or Saturn are? Is there an unknown mechanism at work creating a planet-wide heat distribution system that we've never encountered before? The discovery of diamond rain on Neptune offers another piece of this puzzle. Triton is unlike any other moon in the solar system. For starters, it orbits Neptune in the opposite direction of the planet's rotation, a retrograde orbit. This peculiar motion suggests that Triton wasn't originally a moon of Neptune, but was instead a rogue object, likely a Kuiper Belt object, that was captured by Neptune's gravity billions of years ago. Triton's capture would have been a violent process, possibly resulting in the destruction of any other moons Neptune might have had at the time. What makes Triton even more intriguing is its surface. It's covered in a layer of nitrogen ice that reflects an unusual amount of sunlight, giving the moon a bright and otherworldly appearance. But beneath this icy crust, scientists believe there's a vast subsurface ocean, kept warm by tidal forces generated as Triton interacts with Neptune's gravity. Could this hidden ocean harbor alien life? The presence of plumes erupting from Triton's surface, similar to those observed on Jupiter's moon Europa, suggests that water and organic materials are being expelled into space. This is a tantalizing clue that life might exist in this frigid, remote corner of the solar system. The potential for life on Triton forces us to confront a profound question. If life exists elsewhere in the solar system, what does that mean for humanity's uniqueness? More importantly, how would contact with alien microbes, or something more advanced, reshape our understanding of biology, evolution, and even spirituality? Triton, despite its isolation, might hold answers to questions we've been asking for millennia. But not all of Neptune's revelations are confined to the realm of distant moons or exotic storms. The planet's magnetic field, as chaotic as it is, has implications that extend far beyond Neptune itself. Unlike Earth's magnetic field, which is relatively stable and aligned with our planet's axis of rotation, Neptune's magnetic field is tilted at a bizarre angle and appears to be shifting constantly. This chaotic magnetosphere creates regions of intense radiation around the planet, zones that could destroy sensitive electronics or pose serious risks to any future human explorers. What's even more unnerving is the possibility that Neptune's magnetic field is evidence of an unstable core. If the core is undergoing some kind of internal transformation, could that instability trigger catastrophic events? Imagine the ripple effects of a destabilized ice giant in the outer solar system. How would that impact Neptune's moons, the Kuiper Belt, or even the delicate gravitational balance of the entire solar system? These questions bring us to a larger existential concern. Neptune's new images remind us that the universe is far more volatile than we often like to believe. We think of the solar system as a relatively stable place, with planets following predictable orbits and conditions remaining constant over billions of years. But what if that stability is an illusion? What if Neptune, with its chaotic storms and shifting magnetic field, is a harbinger of greater cosmic instability? One particularly chilling possibility is the idea that Neptune's behavior could be influenced by external factors, perhaps even a distant unseen force acting on the outer reaches of the solar system. Some scientists have speculated about the existence of a ninth planet, often referred to as Planet 9, which could be exerting gravitational effects on Neptune and other outer solar system objects. While Planet 9 remains hypothetical, the implications are profound. If such a massive object exists, its influence could explain some of the anomalies we've observed, not just in Neptune, but throughout the Kuiper Belt. Moreover, Neptune's new images force us to grapple with our own planet's fragility. Earth, with its relatively mild climate and life-sustaining conditions, might seem like an oasis in the chaos of the universe. But what if the forces shaping Neptune's violent storms, internal heating, and chaotic magnetic fields aren't unique to that planet? Could similar processes one day threaten Earth? The thought is both humbling and terrifying. Yet, amidst all the uncertainty, there is hope. The technological advancements that have allowed us to capture these unprecedented images of Neptune represent the very best of human ingenuity. The James Webb Space Telescope, for instance, is a marvel of engineering. Neptune's recent revelations, captured by the James Webb Space Telescope, have illuminated the hidden complexities of the universe, inviting humanity to push the boundaries of exploration in ways never before imagined. These images not only expose the planet's stunning beauty, but also offer profound insights into the very nature of planetary science and our place in the broader cosmos. The discoveries made from these new images challenge our previous understanding and inspire us to reevaluate many of our assumptions about the solar system. With each observation, we inch closer to answering fundamental questions about the origins of planets, the forces that govern them, and the possibility of life in distant corners of the solar system. One of the most striking features of Neptune is its violent and mysterious weather patterns. For years, scientists have speculated about the driving forces behind the planet's extreme storms, but the latest data brings us much closer to understanding the mechanics at play. The storms on Neptune are not just fleeting weather systems like the ones we experience on Earth. They are massive, enduring, and far more chaotic than anything observed on other planets. One of the most incredible phenomena is Neptune's hyperstorms, vortexes so enormous that they could easily engulf the entire Earth. These storms generate supersonic winds that travel at speeds of over 2,000 kilometers per hour, defying the known limits of atmospheric physics. What's even more perplexing is that Neptune sits on the icy fringes of the solar system, where the sun's energy is only a fraction of what Earth receives. In theory, this should result in minimal atmospheric activity, yet Neptune's storms remain among the most powerful and persistent in the solar system. This has led scientists to rethink their assumptions about the role of solar energy in weather systems. The planet's internal heat, presumably originating from a source deep within Neptune, is likely the driving force behind these extreme weather events, but the nature of this energy source remains a mystery. Some researchers have proposed that Neptune's core could contain metallic hydrogen, a form of hydrogen that behaves like a metal under intense pressure. This material could act as a superconductor, creating immense magnetic fields and facilitating the heat distribution necessary to fuel the planet's violent weather patterns. If true, this theory could suggest that Neptune operates on principles entirely different from what we observe on Earth, or even in other gas giants like Jupiter. The prospect of an unknown mechanism powering Neptune's storms leads to even bigger questions. Could similar mechanisms exist on other ice giants in the universe? And what does this imply for the weather systems of distant exoplanets? If Neptune's extreme storms are not an anomaly, they could be common features of other icy planets throughout the cosmos, which would vastly expand our understanding of planetary weather and climate. More unsettling, however, is the possibility that Neptune's internal heat could destabilize the planet itself. Dramatic shifts in Neptune's atmosphere suggest that its heat balance may be tipping toward a tipping point, potentially leading to catastrophic atmospheric changes. If this happens, the planet's moons, particularly Triton, could be at risk. Triton, Neptune's largest moon, has been the subject of increasing interest due to its peculiar behavior and potential for harboring life. Triton's orbit is in retrograde, meaning it orbits Neptune in the opposite direction of the planet's rotation, a highly unusual feature that suggests it was likely not a native moon of Neptune, but rather a captured object from the Kuiper Belt. This violent capture process might have resulted in the destruction of any previous moons Neptune had. But what makes Triton so intriguing is its surface. It's covered in a reflective layer of nitrogen ice, giving it an otherworldly, gleaming appearance. Beneath this icy exterior, however, scientists believe there might be a vast subsurface ocean, kept warm by the tidal forces created as Triton interacts with Neptune's immense gravity. This hidden ocean could create an environment conducive to life, as the tidal heating could provide a stable source of warmth and energy. Plumes of material have been observed erupting from Triton's surface, much like the geysers seen on Jupiter's moon Europa, suggesting the presence of water and organic materials being expelled into space. These plumes could potentially harbor the building blocks of life, and if true, this makes Triton one of the most promising candidates for extraterrestrial life in the solar system. The presence of a subsurface ocean coupled with the plumes, raises tantalizing questions about the possibility of life in the cold, remote reaches of the solar system. If life were to be discovered on Triton, it would fundamentally alter our understanding of biology and the conditions necessary for life to arise. It would suggest that life is not unique to Earth, but may be a common outcome of certain environmental conditions that exist across the universe. The discovery of life on Triton would also force humanity to grapple with important ethical questions. If we find life on distant moons or planets, how should we interact with these ecosystems? Do we have the right to explore, exploit, or potentially disrupt these environments, or should they be left untouched to preserve their natural state? These are profound questions that humanity must face as we venture into the cosmos. As we look ahead to future missions, the ethical implications of our exploration will become increasingly important, especially as we develop the technologies to study and possibly interact with distant worlds. As we continue to push the boundaries of space exploration, technological advancements will play a crucial role in our understanding of Neptune and its moons. The James Webb Space Telescope has already far exceeded expectations, providing unprecedented views of Neptune, revealing previously hidden features and unveiling mysteries that were once thought beyond our reach. But the future of exploration lies in specialized probes and landers that could dive deeper into Neptune's mysteries. These probes could be equipped with advanced instruments capable of sampling Neptune's atmosphere, mapping its magnetic field, and exploring Triton's subsurface ocean in detail. Such missions would be incredibly challenging, given the immense distance between Earth and Neptune, but the scientific rewards could be monumental. Another exciting development in space exploration is the potential role of artificial intelligence, AI, in these future missions. AI could be used to process the vast amounts of data generated by space missions, identifying patterns and anomalies that might otherwise go unnoticed. AI could also be used to navigate the complex environments of Neptune and Triton, making real-time decisions about where to go and what to study. This could significantly enhance our ability to understand these distant worlds in ways that were previously impossible. Neptune's recent discoveries have shown us that the universe is far more dynamic and mysterious than we ever imagined. They challenge our assumptions, inspire our curiosity, and encourage us to think bigger. As we continue to explore Neptune, we are reminded of the importance of perseverance and exploration. The mysteries of Neptune and the potential for life on its moon Triton remind us that there is still so much more to discover, both about the universe and about ourselves. Each step forward brings us closer to a more profound understanding of the cosmos and our place within it. Looking to the future, the secrets Neptune holds will undoubtedly continue to inspire and motivate humanity's quest for knowledge. Whether it's through technological innovation, the discovery of alien life, or the unraveling of the mysteries of Neptune's chaotic weather systems, there is much to learn. Would you like me to focus on any specific aspect, such as the role of AI in Neptune exploration, the ethical implications of discovering life, or the potential for other discoveries within the outer solar system? Let me know how you'd like to delve further into this remarkable journey of discovery.